Internet of Things, IoT devices. Let us explore the massive and complex world of the Internet of Things, or IoT. At its simplest level, IoT refers to the billions of physical devices around the world that are now connected to the Internet, all collecting and sharing data. These are not your standard computers or smartphones. We are talking about everyday objects, light bulbs, thermostats, refrigerators, and even heart monitors that have been embedded with sensors, software, and network connectivity. While these devices make our lives more convenient, they have fundamentally changed the security landscape by creating billions of new entry points for hackers to exploit. The architecture of an IoT ecosystem. An IoT system typically consists of 4 distinct layers working in a continuous loop. First is the perception layer. This is the physical device itself, equipped with sensors to feel the world. A smart thermostat, for example, uses sensors to measure the temperature and humidity in a room. Second is the network layer. This is how the device talks. Because these devices are often small and run on batteries, they frequently use low-power wireless protocols like Zigbee, Z-Wave, or Bluetooth Low Energy, alongside standard Wi-Fi. They send their data to an IoT gateway or directly to the cloud. Third is the data processing layer. This is usually where the brain of the system lives, often in a cloud data center. The raw data from your thermostat is analyzed and compared to your preferred settings. Fourth is the application layer. This is the interface you see on your smartphone. It allows you to see the current temperature and send a command back down the chain to turn on the air conditioning. The security challenge, the S in IoT. In the cybersecurity community, there is a common joke that the S in IoT stands for security because, in many cases, security is completely non-existent. Because IoT devices are embedded systems with limited processing power and memory, manufacturers often cut corners to keep the price low. This leads to 3 major security flaws that you will encounter as a professional. First, hard-coded passwords. Many devices come with a default username and password, like admin and password, that cannot be changed by the user. Hackers know these defaults and use them to take over thousands of devices at once. Second, lack of patching. Unlike your laptop, which receives automatic security updates, many IoT devices are set it and forget it. If a vulnerability is discovered in a smart camera, the manufacturer may never release a fix, or the user may have no way to install it. Third, clear text communication. To save battery life, some devices send their data across the network without any encryption. An attacker with a packet sniffer could easily see your private conversations or your daily habits by watching your smart home traffic. The rise of the botnet. From a high-level security perspective, the biggest threat from IoT is the creation of botnets. When a hacker takes control of thousands of insecure IoT devices, they turn them into zombies. The hacker can then command this army of devices to perform a massive DDoS attack. This happened famously with the Mirai botnet, which used compromised smart cameras and DVRs to take down major sections of the internet. The individual owners of the devices never even knew their hardware was being used in a global cyberattack. Defense and best practices. To protect a network from the risks of IoT, security professionals rely on network segmentation, a concept we discussed with VLANs. You should never place insecure IoT devices on the same network as your sensitive servers or your personal computers. Instead, you place them in their own isolated IoT VLAN if a hacker manages to compromise a smart light bulb. The VLAN prevents them from pivoting or moving laterally to steal your files or your passwords. Furthermore, you should always check if a device allows you to change the default password and support multi-factor authentication before bringing it into a professional environment. By mastering the balance between the convenience of these small embedded devices and the strict requirements of network isolation. You will be prepared to manage the ever-expanding digital footprint of the modern world.